Today the topic that we are going to cover is kind of technical. It's about the accelerator that we are building in Unison, and I'll try to make it sound as easy or as humanly possible, like for the audience involved. Probably like, yeah, I'll start. And if you have any questions or query, you can stop me in between and ask, or we can have a separate question and answer session at the end as well. Let me quickly walk you through like what I'm going to talk about or present today is it's called as Databricks AWS platform accelerator. So this is nothing but like when a customer or a client of Unison wants to migrate, right? Like so far we have been like seeing so many migration accelerators, like so many we have heard, right? Like in our previous DataSpark sessions. So if a customer wants to migrate from their existing, legacy platform to AWS, I mean, and Databricks, AWS plus Databricks, right? So in that case, this accelerator will help us set up the basic infrastructure that's required for this migration to be made feasible. And we'll see like what is the problem or issues that we have at hand and what this accelerator would solve. How have we designed this accelerator and like what features it brings to the table, right? This is the intro. Like maybe I'll just give a few pictures about like what is Terraform, what is AWS, what is Unity Catalog, that's presented over here. So Terraform is the enabler or the core. He is nothing but like the infrastructure as code. Like this will help us create resources on both AWS side and the Databricks side. So you can think of Terraform as enabler. Like for this, it's going to be a code who's going to deploy this for us in both the platforms like AWS plus Databricks. So in AWS, we are going to cover certain resources, and in Databricks, we are going to cover a different set of resources. So these are going to integrate together, and we'll call them as pillars. So like certain resources are grouped together, and they are called as pillars. Like maybe that's how we will start. So just to have a mental picture of all this, right? And YAML is nothing but it's going to be a configuration file. Like it will maybe in later stages, it's nothing but the input that we are going to provide through the YAML. And this YAML will go take this input to the Terraform code. This code with the inputs provided is going to build your resources on both the platforms. So we'll probably see what this accelerator is all about. So what the issues we have at hand currently is if you want to set this up, right, like this infrastructure, the base infrastructure, if a customer wants to move from legacy to either an existing, platform move or a new customer who wants to create a workspace, this enables, I mean, like this accelerator is for all the kind of customers who wants to migrate or who also wants to set up infrastructure from scratch. So the problems that we are going to solve here are going to be, like for example, the first one is weeks of manual setup. Like if you want to do the setup by manual using some experts, you need someone with Terraform experience, you need someone with AWS native experience, and you need someone who knows Databricks very well, and with some CI/CD touch as well. So all this is required, and this will take weeks to complete. But if this accelerator is there, it's going to get your work done within, few hours or few days. Like the days in the sense, because if you want to understand a customer well, you need some time, and then you get the inputs, then populate that, run this accelerator using the inputs that you get from your client or your customer. So that's what it brings down to. And next is, currently, like so many organizations, we have seen like people struggling with different environments setup. For example, even today, even till date, like people don't have a different environment setup that before production, right? Like they directly make changes in their production environment. They face so many issues because of that, and they have to do debug things on production environment, and they face so many backlashes and cost degrades because of these issues, right? So we usually suggest like always go through code promotion, like you promote your code to a dev environment, and then you go to staging, and then you go to production, right? So all these, you have to make sure they are identical, right? Like with respect to their own environments, few things might vary, but not all, right? Like for example, production might get the live data stream, but dev and staging environment, they're just for testing, right? Like dev is for the developer to test whatever he has developed is like right and working, right? Like that functionality is working. And staging will be for the UAT team, who is going to give a sign off, like mentioning like whatever features were requested are there in place. So right, like all these things will happen in the staging environment. Production, if all is good, your code is going to go live, and then you're going to run. But the thing is, now in nowadays, like in most organization, this kind of setting is not followed, and this standard, if it's not followed, it's going to cost them heavily because of faulty code structures. So this Accelerator even solves that. Like we are going to deploy these infrastructure for them with a specific environment wise. And there are many things like come in picture, like when you develop something in manual setup, right? So security gaps are the most frequent ones that you can see. For example, if you have misconfigured something, like when you do it manually, like errors are bound to happen. And like when you misconfigure something, right? A private link, your data is vulnerable to the outside internet. And if you have some IAM roles, and sometimes by mistake, if someone manually gives, yeah, he can have all the privileges, then the thing is, again, the data underneath and the objects underneath have vulnerability to user specific reasons. So these are the things that might come into picture. And like when if you want to keep your data, like see the customer thinks like, see, I want my data to be protected when it's at transit. So they will take it, like when you make a call from a client side to server side, you make sure that data is encrypted, right? And you they also want to make sure like my data is safe even when it is at rest. So here the data will live in AWS S3, right? And even from there are many types of encryptions that's happening at S3, like where your data stays securely. But like if if to keep it highly secured, you can have this KMS encryption. That's one feature of S3, where you will rotate your keys. Maybe this is too technical, but just to give an idea, where you have for example, a lock pattern, like how you have it in your phone, to make it simpler, right? In simpler terms, you have your phone, you have a pattern. So iPhones are just like, get your pattern changed like within 6 months or 3 months, so that it's regularly rotated and leakage happens very less, so that your data is secured most, right? So this is what came as, is nothing but it's a different kind of security pattern or password, right? So this will take care of that encryption, and this is enabled in the Accelerator as well. So again, migration, like if your base or the foundation is not even ready, like then what will the upstream, like the data engineers will do? They'll have to wait until the infra is ready to move their data here, and the downstream consumers are also affected because of this like migration delay. The infrastructure itself is taking some time, and the data is halfway here, halfway there. Then again, like they have to wait again, like all until all is set up and all the infrastructure is completed. So to avoid all these problems, we are bringing in this accelerator. So from day one or from day 3 or 5, like all your issues will be resolved, and you have a ready infra at AWS and um, Databricks side. So why the move to the cloud? So Databricks, they run on a cloud platform, right? Like they use the cloud platform as their base, either Azure, AWS. But there are so many reasons where we can, one thing that you can think of is like currently many customers, they have AWS enterprise licensing. So that is one major reason that we wanted to go for this accelerator first. Right, like probably we'll come with the different accelerators later on in stage, but like now, this is the one that we are going forward with since it's in high demand, and uh, uh, this is how we structure Databricks too. So why they have moved to cloud? One is you can, for example, if a customer or a client, he can't like now buy hardware and data centers, they don't want to do that, right? Like no one wants to manage and patch servers like the old or traditional method. It's costlier. It requires much more resources to handle these issues, right? So now everything they move it to cloud. Your data is going to live on the cloud. You're going to control your data in the cloud through your control plane, like of the Databricks, right? So once you do that, you can like on demand, like whenever there is a high requirement or high peak of data, like you can increase your clusters whenever it's required, and then you can scale down. Like then you pay for whatever you have used. So it makes your job much more easier. So, and this will also eliminate maintenance. You don't have to have some engineer go down to a data center, fix something, right? Like that's all gone now. Like, and we know, and I know, like most of you know, like what's the use of cloud, but this is the most important thing that I just wanted to share through this. And again, whatever is coming new, whatever third party tools are there, you just have to, it's like a plug and play. You just install and then you use them on handy, like whenever you have a cloud environment. And the additional things that I can that I've listed over here, they are you build a lakehouse architecture using this, and everything is going to be handled in a single platform. You're going to have delta lake tables, which are going to be your source of storage. And again, you can use this as for data warehousing. You perform ETLs, and then the end consumers, again, they are in the same platform. ML usages can also be done. You can create your models. You can have your ML, an analyst, data analyst to come in and perform some analysis, and like then we get the trend or the pattern of the data that's coming in. And AWS by its native, it provides S3 for storage. Like if you see, Databricks have their own kind of variety of storage. Like for example, if you want to go with, they have two types, like internal and external. So internal is that's something managed by Databricks itself, and external is you say no, I'll pay for it, I'll manage it outside, I'll take care of the data. You don't have to worry about it. It's taken externally, and the client, whoever has a AWS platform, they're going to store it in S3. So this storage, it's again, it's easily integrated. This integration is feasible in Databricks as well. So then again, you have IAM role, like cross account role for your Databricks and AWS. And all these setup that are natively like available in AWS can be easily integrated with Databricks. So these are the reasons why we are first like going. The major reason is, as I told, it's like high on demand, and like this is what is trending now. So we are also building the accelerator for that specific reason. So how this accelerator is built? So before this, probably I'll skip few and quickly show you how, yeah, the architecture is, right, like how it is built. So there are many things that come in, right? Like these are the pillars. We'll come back to this later point, just to give a picture, right? So this is our data plane, right? Like our data plane will live in AWS cloud under a specific, virtual private cloud. So this, you mentioned all these details in the config.yaml. I'll say what the YAML is. We are going to look into that like later. And we have our private subnets where our data will live, and the public subnet to get your control plane signals and then talk to your private subnet. And like if the private subnet wants to talk to the NAT gateway to the internet, it can do, but it's only for outsource, right? And then you have your data plane, Databricks control plane. So in the control plane, you can do all these functionalities. Maybe we'll come to this, again, and like later point, we'll have what it is about. So yeah. So how we have built these accelerators, we are having 5 pillars, as I told you. So these 5 pillars are nothing but, one is networking. This networking will be built on the AWS cloud. And this is for the virtual private cloud that you're going to create, and you're going to put your other workspaces and cluster under these virtual private cloud, because the customer or a client doesn't want their data to be, uh, accessed by any other outsiders or any other unallowed or unnecessary traffic incoming, right? So networking will take care of that part, and we will have to get these inputs from the client, right? And cloud infra, again, this is for one is for the cross account, accessing, that is like from Databricks to AWS. So the other is for, here we build S3 buckets for the data that we are going to input into the AWS storage. So for example, like currently we have, S3, we use it for state file management. One is that is like when you deploy something through Terraform, the resources state will be managed through something called as a state file. It's like you can take it as an index, like when you create some document, you just have an index, you say, okay, so this is what is changed, and you have all the detailed explanations of what is changed, what status it is in, and you have it as a index, like it will say what is happening to the resources, right? So this will have to be stored in an S3 location, like it will be in a remote location, like when you deploy from a local or a different uh, you know uh, uh, location. So this will be stored. And the other things that we create for the specific, accelerators, since we have the medallion architecture being followed in Databricks, I believe you would have known. It's nothing but, there are certain medallion, architecture or a lineage it follows. Like it's, when the data comes in, it falls in bronze. And, when the data is raw, it is raw in bronze, right? And once it's curated, and once it's like some cleaning is done, it is then moved to silver. And final aggregated data will be moving to gold. So we create buckets for all these specific layers. So that's what I want to talk about. And we don't have to go in more depth, just like to get the mental picture and like the clarity on what these things are, right? Like if in case tomorrow you want to talk to one of your clients and customers, I just want to give you an idea or a brief, like how you could probably take it forward. So next, the third pillar would be like the workspace and the cluster. So this is where you will be doing all the control planes, and that your data would live. So you create your workspace to access these catalogs, schemas, and tables. And the clusters are nothing but, again, like when you want to run some, like how in old days, like we have a processor to run things, right? So that's what cluster is going to do. We'll probably take a more deeper look, like when we move to the next pillar by pillar, right? And then user management. Again, user management comes in handy when, see, like currently, like what happens? People go in, like they just add a user to a specific workspace or a specific account, and then they give the privileges that they want, like whatever privileges. Like if they are over privileged, they can access anything, they can delete something by mistake. So in order to avoid that, we have the least privileged users and groups being created as per. I mean, they have to import it to the config.yaml, as you can see here. And then this will be again translated into the Terraform code, and our resources will be built accordingly. The SIM is one thing that I want to bring it to your attention. So if a customer or a client have an IDP that's already existing, right, like an OTKA or a Azure AD, they might have their users and groups already available over there. So if they want, in case, like Databricks now allows like direct integration of this SIM, like with the details that you have given, like if you give your token and secret, you can directly integrate them. You can bring in all the users and groups that are part of this IDP. So if a user comes in, right, like he can directly be added to this Databricks workspace. If he leaves by any chance in few days or few months, then again he can be automatically removed once this is being updated in the IDP. So that's what the sync is all about. And then Unity catalog governance, again, like it's going to be a fine-grained level of governance. So this also be set up with all the metastore. And I mean, what we are building is the basic infrastructure or the foundation. But later in point, if the customer wants to, develop or make it more resilient to something, then they can keep on, improving. But this accelerator is going to help you build your foundation from scratch. So maybe this is how the config file will look. It's going nothing but a key pair, set of list. You can take this, as a form, like take this in mind as a form, like where you have to fill in certain details as like what region this project is going to belong to, and what is going to be your workspace name, what name should I give, like who are going to be your team members, what kind of accesses should they give. So all these, like, right, like your workspace name and cluster policies, like what kind of configurations should they have, and the VPZ details, the private subnet details, all these things. Should we enable private link, should we enable NAT gateway? So all these are handled through the Terraform code based on the config YAML we given or we provided to. So the brain of this accelerator is nothing but the config.yaml. So just few more, like a bit in depth, right? Like how it's happening. So this is going to be your single source of truth. I'm just going to get what details are required in this config.yaml. And this parcel, there's going to be YAML parser who's going to read all the values from the keys that's given in, right? And then consider this Terraform variables as nothing but Terraform. What it's going to do, it's going to create your resources, right? So it's a code which will create your resources, and you're going to inject these into the variables. Variables are nothing but like the inputs that's required before you start creating or building your resources. And once you do that, all the resources will be great. How Terraform is going to do this? It in the backend, it's going to talk to some API, right? Like if it's going to create some resources in AWS, it's going to be AWS APIs. And if it's going to create some resources at a Databricks side, then it's going to be through the Databricks APIs. So again, like once you give these inputs, it will take these inputs along with the resources it wants to create and go to both the platforms and then create their own set of resources. Just for example, like for how maybe a simple one I'll show you. Workspace dot auto termination minutes, I set it as 30. So what it's going to do, it's going to translate the same to this code, right? Like I'm going to get this value, whichever I set in the config.yaml. In the end, what the Terraform is going to do, it's going to deploy a cluster. This cluster will auto terminate itself within like the next 30 minutes, right? Like once if it's inactive, it will auto terminate. What is this going to do? It might not seem like a big thing, but it's going to save you so much cost. Like if clusters are running idle like throughout the weekend or throughout the night, it's going to cost you so much DBUs. DBUs are nothing but some Databricks units, but it's going to cost you money, right? By the end of the day. And customers don't want this. So all these, important setup or the best practices are being handled by this accelerator so that we enable and disable whatever is required. We go with least privilege accesses, and we create catalogs and like whatever is by minimal required to start a workspace and run something with the data, right? So that is there. Okay, maybe now we'll go with pillar by pillar, but so I'll try to make it light, right? Like let me know if I'm not doing that. But I'm trying to explain each concept so that it's easier for you to take it forward, as you will definitely need to in some point, right? So I'll try to give much clarity as I can, but yeah, let me know if there are any. Okay. So next is pillar one, networking, right? So this is nothing but like again, you have to once if you have your data, if you have your all your setup, even networking is most required because this is related to security, right? Like it talks about all the secure things that you're going to do to your environments, right? So first, what are getting created through this accelerator? I'll talk about that. So it's going to be a virtual private network. So your data stays and everything stays within the cloud. And you built it with the custom CIDR is nothing but the IP ranges, right? Like some private IP ranges that you're going to give. Organization might have their own VPCs and their own subnets that's already available. If so, we just map them to this, right? Like you just get the inputs, you provide it in your config.yaml, and then you run it. And like, I mean, when they start, right, like when they want to do this, they can do it. And NAT gateway for like outbound traffic, as I said, that's used for if you enable them, you can access the internet and get the like for example, if there is a software update that you want to do, that can be done through this if you enable it. Private link is again like if some communication has to go through like with Databricks and AWS, it will do it in the backbone of this like through the private link, so no data is leaked to the outside traffic, right? And security groups, for restricting, this is nothing but like firewall. Again, like who can access, if there are certain IPs that are blacklisted, you put in your firewall rule, don't allow these, right? So these can be again restricted using these config.yaml, like whichever groups or firewalls you provide, all these will be configured with that. So that is with respect to networking. This is just like a idea of like how the module will be triggered. There is a backend code that will be called after this. But like once you give all these details will be passed using the parser, and then like they'll be consumed using the Terraform. So probably we'll move on to the next. Yeah. So pillar two is cloud infrastructure. So it's nothing but again, first networking. You built your VPCs, you built your NAT gateways, you enabled your private link, you set all that up. So next, you have to build your infrastructure on the AWS side. So why this is required? S3 buckets. It's required to store your data if you want to put your data in Databricks, right? Like so, the underlying or the storage will be in your S3 bucket. Even if you say it has to be managed with Databricks, it's again like they will manage it, but again in some cloud platform that they choose, either AWS or Azure. So if it's going to be your own cloud platform, it's well and safe and secured with your own accounts. So what are we going to create using this S3 buckets? It's going to be again like per catalog per layer. We are going to build these S3 buckets. And what best thing that we follow? Again, bucket policies also must be enforced with least privilege. So accesses should be with least privilege. Least privilege in the sense you don't provide full access, only the access that's required. So to start with, we give the basic access, like just read, you can just view, right? Like, but nothing else. But if later in point, if a user wants to write something to it, or if the user wants to delete something, if they want to manage or modify, right, all these can be done in later stages. But again, make sure they have to, the user or the client have to make sure that they don't over privilege a certain user or an group, so that it doesn't end up badly for them in later stages. And we also make sure the data is at rest, they are secured through this KMS key. And even this, we get it as an input through the config.yaml. Do they want KMS key rotation? I told you, right? So like when you want to change your iPhone pattern, this will be have to be manual, right? Like if you want to do it in an automated fashion. So like the system will know once the password is there, it will use that KMS key to encrypt your data, right? But the scheme is key. If it is leaked, someone can decrypt your data and get it back to you. So you on a regular basis, there is a again like an automation built around it. It will automatically enable your or rotate your key in a specific period range so that the data or the key is not leaked and it's not compromised at any point. So even that is taken care of. And again, IAM policies and roles for cross-account trust, like from the Databricks control plane, you have to send signals. You will use this IAM account. You will have to, this again is in a configuration at the Databricks side. So using that, it will talk to the backend AWS account. So this is required, and here also we make sure that you don't give privileges to everything. Permissions are very scoped. And see, again, like this is what, like no wildcard permissions ever. That is one thing that we have to keep in mind. And in this accelerator, we have built it in the same way. And even we usually like, because since the clients who migrate or come to a new database platform, it's new to them too, right? Like, so the standard and best practices we have to keep repeating so that the user or the clients like follow this as a thumb rule. So we basically try to educate this at most as possible. So I'm even sharing the same. And again, like we set up auditing on monitoring. This is most required and loved by the clients. They always want to know like what, again, like these all can be fetched later in points if something, bad happens, or if some debugging is required at our end. So we can have the cloud rail is nothing but it's a service provided by AWS where everything will be logged, like which user, what is the user ID, like what did he try to do, was it a get, was it a post, what kind of call was it, right? So all these will be logged, and this we have enabled. And CloudWatch is again another service where we can set up alarms. These are nothing but if some cost or usage, if it's breaching, if it's above the threshold, again these will alarm the user or the client if something bad happens. So similarly, we have this KMS key rotation enabled, and we will use the secret manager services. We don't hard code things, right? We don't hard code data, I mean, secrets values directly at code, or we don't save it in environment, but we go for a secret manager service that's managed by AWS. We put our tokens, keys over there, and then we automatically fetch it during the runtime. So these are some best practices that get followed in this accelerator. And yeah, that's mostly for what we are building on this cloud infrastructure side. And then again, workspace, for example, workspace and clusters, we are building something with whatever is required. If a customer wants, he can extend this and build the same. It's always best to go through or create some resources through a Terraform or an infrastructure as code. It can be any. There is also something in native provided by Databricks, such as that's called as declarative automation bundles. So this is also similar to Terraform. It will help you create resources through code, right? It's not directly in UI. You don't create some table something or some cluster, but you create it through a code. You just mention your configurations and then you create it. So if something happens, some issue happens, you can just rerun this so that it will be automatically fixed, rather than people doing it manually and something gets built day by day and it fails over at certain point, right? And with this we can even also allow certain node types, so that we have restricted these with certain types as well. For now we are building with the basic, but if required a customer can increase or scale it up later. But since we don't want any user to build some clusters using these policies, we don't want someone to spin up hundreds and with so many big cluster sizes, right? Like that might end up give so much high cost at the end. So a client also would want to keep this in check. And we have seen organizations so far like who really wants, I mean, cost and usage is like highly important to organizations. They try to make it minimal and optimal, right? Like they even want it optimal, but like they try to make it minimal. So these small things that we are taking in hand and we are trying to make it as a standard practice, right? So this will make sure this accelerator is built in a way that it will make sure that these are kept in check. So yeah, this is what we are going to enable, and we are going to have auto termination in place. As I told you, you don't have to have auto termination on all. I mean, auto termination, if it's disabled, it's going to keep running, and then it's going to give you so much cost. And policies enforce like how much max nodes certain user can use, like t-shirt sizing of instances, right? Can they use like a very big cluster, or should they stay with the small or a medium sized, right? So all these we have enforced, and it depends on the user to give all these inputs. So if they think like their data requires highly configured setups, then they can go for the larger node types, and then they can allocate it to certain groups too. Like for example, like when a groups comes in, they can be assigned these policies in their entitlements, so they will have access to whatever they can do with. So certain best practices followed in workspace and clusters, and that's what we are seeing here too. And user management, as I told you, this is one important aspect. Like we provide config YAML. In config YAML we get user specific details too, but it is always better to directly integrate their IDP like Okta or Azure AD. So if employee is listed there, they'll be directly added as a user in the Databricks account as well. And once maybe like if an employee leaves the company, right, they will directly be removed. So again, group permissions also will be changed accordingly. Like it will be propagated to Unity catalog. For example, you get your employees who are in Okta or Azure AD directly through the SIM protocol. You will sync it with your users and groups in the Databricks workspace. So users will get the correct access over here. You are maybe assign them certain entitlements. So with that, they will know like what clusters they can access, what catalog that they can access in the catalog grants, right? Like all these will be provided. And with that, you can manage them in fine-grained details. So user management is done again, like also enabled through this accelerator. We also facilitate this SIM integration directly, or you can directly even create users with specific roles and assign them. Even that is feasible. That's also pitched as an input from the config.yaml. So this is also built using the accelerator. And again, Unity catalog and data governance is one other thing that's built using this accelerator. So we are going to have a meta store in place, which is going to manage all your work, I mean, govern all the workspaces. So this is created through this Unity catalog pillar. So once that's created, like you will have your catalog to created with the schema names, and the tables also will be mapped under the created under these in later point. But this is what this again I told you, right? Like this is like the skeleton of the infrastructure that we are going to have, but later in point it can be developed more, or it can be utilized by the data engineers directly. But even if they want to go ahead with later stages, they can use infrastructure as code to build these resources. So yeah, after these all these data lineage, column masking, all comes under this pillar. So it's easier to track which data set is using. I mean, which object is using which data set. So like the upstream and the downstream also will be tracked, and these details can be fetched using the Databricks workspace itself. It can be done in the Databricks workspace itself. So this all can be done using the data governance part. So like all this governance audit, it's all like enabled using the catalog tool, and I mean enable using the Terraform resource code. So like we have given with the least privileges. Again, if the customer or the client wants, he can since we have provisioned this as a skeleton, later if they want, they can modify it as per their requirement. So this is how the process flow. Like I think this will be more important. The next two slides will be more important, I believe. So first, how this process will look like. So when a client or a customer comes in, so this is how it starts. So far, whatever we have seen is like the technical aspects of the accelerator. I just try to give a brief so that you understand, like, if you want to talk more about it or explain it to a customer, right? But like how this process will go, right? Like this will start with the discovery and assessment of the customer platform, the existing platform, like how they are, like how they want it to move, like do they have the IDP, do they have any IDP? Can it be integrated? All these details, right? Like you get all the network topologies, like for the networking aspects, right? Like how they want their VPC to be built and all these details. And after this, you configure your YAML with all the required. Once you get your inputs, right? Like you get it with respect to the YAML itself, and then you configure your YAML, you give the inputs, like how they want to name it. Like usually we also can provide them some standard naming conventions, but if they are already following some pattern or convention, we can even like use that and add these to the config.yaml. So everything will be like taken as an input using this config.yaml. So it's a single source of truth, and the code will be building that using that. Right. Again, so to run the accelerator, we provide some shell scripts like a bootstrapped script and validate script. That is for now, but later in time, like we have planned to have it as a UI wrapper where a user can come in. They can just input some form, right? Like we get the details that's required, that will be fed to the backend, and the backend once it might be some detailed UI page. Like we have a slide on that. Maybe we'll talk about it later. But what the accelerator is going to do, it's going to do some init and apply, and then it's going to again make some sync trigger, and it will have your Unity catalog bootstrap. Like it will be started with all the necessary catalogs and schemas, like the basic ones, right? And all these are going to be done at the accelerator run. So once these are done, so this is what, like this config kickoff and everything, it will be like, you take some 1 day time to discover and assess like whatever is required for them, right? And then you run this. Running, it's going to take only few minutes to hours, right? Like, and then you do some validation, some smoke test, like to see if all network connectivities are there, check if the IAM permissions are given. IAM is nothing but like access and identity access and management, right? So you check whatever roles got created, are they having the right permissions, are they able to access? So all these user login validation, these things will be done in the validate and smoke test. And once all is done and once all is good, you hand over and enable them like with the basic infrastructure setup that's required for them to move on there from. They'll have to take it further after that. And we will provide the runbook and like all the documents and the guide like which we enabled for them, like in using this accelerator in this migration, right? And this is one thing. So here, usually, like if you want to do this, right, like it takes like long time, like it takes weeks and weeks of manual effort. But here, since this accelerator has come in, it's going to make it so short. So the most, time-taking process would only be the discovery and assessment. Once it's all there, you just click or run off a particular accelerator, and then it's going to build your infrastructure from scratch. And this accelerator, what it's going to do, it's how it's going to save our time, our numbers, our cost, everything, right? So this usually like in that's what like I told you, right? Like it's going to take 4 to 6 weeks with manual effort, but this will be like very quicker than that, like just 3 to 5 days. So 85% of your time is saved. So all this again with different environments. So you're not it's not just one environment. It's not just production environment. It's going to be different, like dev, staging, as per the requirement of the client or the customer, right? So like you will save hours, like 40 plus hours like per environment. Like again, it's going to be weeks, but it's just going to be hours for per environment. So 3 times the save, and this is going to get your environment ready with zero security gaps and like governance from day one. So usually I've seen in organizations like they create something and then they just bolt on like whatever is required, right? Like they just try to add, and sometimes it might be deleted by some other user. So if it is not managed like by some automated code or automated fashion, again manual errors might come, and like people might one person, one user might input something, and one user might think no, it was said in this way, and they might change it later, right? So all these confusions and chaos will happen. So better this accelerator will build the base, and it will be with the standard and best practices that's required. So what gets automated, as we told, like the networking, VPC subnet private, usually it takes 2 to 3 days. It's with the accelerator, it's going to be built with 10 minutes of time, not even 10 minutes. Like if it's like a very much more. As per the resources increase, right? Like it might take some time, but like I had a demo. I mean, like I built something, right? Like it just takes like around 5 minutes or something. So not even 10 minutes. So I can say, and IAM roles again, once you have linked your AWS account, usually takes like 1 to 2 days to identify how to link this, like with manual work, right? So with this accelerator is going to be less than 5 minutes. And similarly, like all the setup, like which usually takes like 3 days, 2 days, and days of work, right? So all these are now reduced to minutes. So however, like it has, brought down like 90% of the work is done like or reduced with this accelerator. So I wanted to showcase this, like in case how this accelerator is going to be efficient for them. This is how. So it's going to be more, uh, you know, following the required practice and be more flexible for the user or the client. So this is what I was just talking about, like the UI wrapper. This is a plan or a milestone in place. It's not yet implemented, but it will how a user or a client who comes in tomorrow, whoever wants to access this accelerator is going to work on it. So they'll just have a form based view page, and they just have to input whatever requirement is needed for them, or they just give the inputs and we do it, right? Like for the end client or customer, and we just have to validate, and then these are see whatever the user comes in with. They don't want like code understanding. They don't want what Terraform is going to do. They don't have a problem of writing any code or syntax, right? They just have to input like whatever details are required for them. And once they do that, we just do a one click, and it will deploy to a specific environment. And we have currently enabled it as either you deploy it pillar by pillar, or you deploy all the pillars at once. It depends on the customer and their needs, right? And again, like each click, it's not going to create new resources. It's going to be idempotent runs, because we have a state file, a log file that's already in place, which will check for this. And again, like this is another thing that's in the milestone, that we will get it GitOps ready. So you don't have to we'll have the GitHub actions as well, where CI/CD can completely be controlled, right? Like it doesn't have to be more than a plug and play. This is going to be a UI enabled automated way of deploying things. So that's how the plan is, and for this accelerator. So it's still in a progress and still in work, and but this is how we have designed and we have taken it so far too. So all these things are in handy, and like we also have enabled multiple environments by design, like dev, staging, and prod. And sorry, yeah, and we are also following the best practices by default, and we are also going with each pillar by pillar, so it's like not touching the other rest of the pillars. Like once one pillar is deployed, then we go with the next. We can check it pillar by pillar and then move on to the next. So as the architecture we saw, so the Databricks workspace and the clusters, which I told you about, like the SQL warehouses are nothing but, where this is like a optimized compute, which will be used for SQL queries and making it faster in Databricks. So they use a special type of engine called as Photon, which works on, which is built on C++, and this will make the query run faster. And so complex queries can be done within minutes or within seconds, which usually, like in other legacy platforms, might take some hours or days, right? Like those can be squeezed onto and like planned well and processed well too. So you need SQL warehouses, clusters for that. And you can also build some process or workflows using the jobs. And all these things will be built on the private subnet. In the AWS side, we are going to have CloudTrade, CloudWatch, S3 for the data storage, and KMS for the key rotation, as I told you, like to keep it secure, right? And the public subnet, like for private link to, if your Databricks control plane wants to talk to the private subnet, you go through the private link, and NAT gateway for internet access. If your private subnet, if through that, if you want to talk to a public internet, then you can do that for some updates or some patches that's required. And from this, again, all these will live inside your VPC, and all this will be inside your AWS cloud. And your Databricks will have these control planes where you can have your account access and workspace admin, settings, and your cluster manager, like job scheduler, if you want to schedule your jobs. All these you will take care in your Databricks control plane. So control plane will not have any data. So all your data will live within this. It's just going to be whatever control signals you give to. So that will be acted upon your workspaces and your data under them. So that's what this accelerator is going to help you with. So what we are going to build with this is the all five pillars, with your network security configuration in place, Unity Catalog bootstrap, your user management in place, like with the REST privileges, and I mean, whatever the config.yaml input has gotten from the customer, right? So all these will be taken in uh, into account, and the customer then, once all this is set up, they just have to kick off with their pipeline runs. So their data is then transformed, processed, and then consumed by some downstream users. And one more important thing that I want to bring it to your notice is there are other accelerators that's been built by Unison. There are so many in pipeline, but like these are already available. So I think data quality accelerator is yet to be, I'm not sure if it's built, but like these are in plan. And SAP BW to Databricks migration, Redshift to Databricks migration is all available. And there's also a utility or a migration accelerator that's for Ranger to Unity Catalog. So as I told, like there is a Unity Catalog pillar that we are building, right? Even Apache Ranger policies that the existing customers have, they have built a migration toolkit for that too. So we already have accelerator that belongs to Unison for this specific use case too. And I believe like this can be taken in the future DataSpark sessions by the creators and the developers, but we wanted to bring it to your notice as well. Thank you.
Thank you, Akshay. The session was really
Thank you.
nice. Yeah.
Thank you. Thank you. Thank you, Sai.
Yeah.
Yeah.